How do you determine the velocity using displacement time graph? Okay, before I go any further, you must be familiarized with gradient of a straight line graph. So if you are unable to recall how you calculate the gradient of a straight line graph, please pause this video and go back to your secondary 1 or 2 maths book and revise gradient. If you can recall, please continue. Okay, to determine the velocity, so this statement I'm writing is a very basic fundamental. So velocity equals gradient of displacement time graph. We call it ST graph. Okay, I emphasize again, in the earlier video, letter S stands for displacement. Right, so gradient of displacement time graph. Now, how do you get the gradient? You're familiar with this idea of rise over run in your lower secondary maths. So how do we get a rise over run? Let's pick two coordinates. Alright, let's randomly pick two coordinates. Let's pick time equals 3. Okay, time equals 3. And time equals 7. Alright, time equals 3 and time equals 7. Okay, so when time equals 3, displacement is 6. And when time equals 7, displacement is 14. Alright, now, then how do you get rise over run? Let me demonstrate in different ink. Okay, here's your right angle triangle. Right, so this is your right angle triangle. And to illustrate rise over run, this is rise. I'll write it further away. This is rise. And this is run. Okay, rise over run. Right. So when your time increases from 3 seconds to 7 seconds, the 7 minus 3 equals 4 seconds. So when the time increases from 3 to 7 seconds, the displacement increases from 6 to 14 meters. So final displacement is 14, your initial is 6. That will give 8 meters. Right, so you rise 8 meters. So rise over run will be 8 over 4 equals 2 meters per second. So your velocity is 2 meters per second.